Thanks a lot for your kind words. And yes, I remember very fondly the time I spent in the monastery at Ivrea a few times, when I visited and so on. So today I want to share with you some thoughts about the topic we are discussing. And when I started thinking about the topic initially, I wanted to take a stance similar to Alessandro's. So, the first thing you're thinking about is AI is something different, and let's try to use design to humanize AI, which is the topic of the session we're discussing. But then I was thinking about some of our recent projects, and I thought maybe there's something else that's going on. And actually, AI is already part of the process of design. And somehow, actually, AI, if we bring it into the process of design, it can help us humanize design itself. So almost the other way around. So I wanted to try to look at this from this lens by switching the two components. Looking at a couple of projects we've been doing recently. But before that, I wanted to start with a few images of the future that date back to the early 20th century, 1899, 1910. We're in Paris, and a bunch of artists try to imagine the future in the year 2000. And they got something right. For instance, they saw, what happened? For instance, they saw mechanization in agriculture coming. That has actually happened. They even kind of foresaw Roomba, the little robot to clean your home. They saw it like, over 100 years ago. But they also got a few things horribly wrong. So they thought we would actually move in our oceans like this, with whale buses, or that the police would move in our cities like this. And even if you are a drone enthusiast, even in your wildest dreams, you haven't seen this happening yet. And here I'm trying to make 2 points. The first point is a point about the future. The point about the future, and here I'm just drawing on the great Karl Popper to make it, is about that the future is impossible to predict. The future is open. It is not predetermined. Maybe today, getting out of this conference, or in thinking over the weekend, we'll come up with some ideas that will change and shape in a different way our future. So Popper says, it's not predetermined, it thus can be predicted, except by accident. That's what happened with those postcards from early 20th century. The possibilities that lie in the future are infinite. And, well, what is a way to explore those possibilities? Really, it's about design. Design is a way to look at how we can turn the present into the future. And here I want to propose that we take a broader definition of design, something we could call design at large. But it goes back really to Herbert Simon. You might know Herbert Simon, a great mathematician, scholar, economist, won the Nobel Prize in economics in the past century. So Herb Simon, wrote a beautiful book called The Sciences of the Artificial. And he says the natural sciences are concerned with how things are, but design looks at how things ought to be, how things could be. So through using design, we can actually turn the present into possible future. And what I would like to argue today is that thanks to AI, we can rethink design. Is AI, many other things, we can enlarge design, and hopefully that can help us tackle some of the big challenges of our time. I really believe that design, if we continue doing like beautifying useless stuff, as it happens a lot when you go to Design Week in Milan, but a lot of the things you see at Design Week in Milan, and well, I'm not saying Milan is an amazing week, but what I want to say in the things we're discussing, then design, then is going to be oblivion for all of us. But if we're able to rethink design and actually leverage new tools, including big data, AI, and so on, to design in a different way and tackle the big challenges of our time. Think about segregation in cities, think about climate change, and so on. Then, then there's hope. Then it can be like Bucky Fuller would have said, it's not oblivion, it's utopia. So I want to share with you some of what we're doing in two particular projects. But first of all, just a couple of words about, thanks JC for mentioning our focus on the cities and on data. We're passionate about cities. Just if you need to remember 4 numbers about city, remember 2, 50, 75, 80. Cities are only 2% of the surface of our planet, 50% now, 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a bit more sustainable, that can be a big deal globally. And one of the things we can do today is really bring into the process of design, data, analytics, artificial intelligence. Today is a little bit like something similar to what happened 20 years ago. So 20 years ago was mostly about taking the physical world and digitizing it. And all the big companies we know today, the Googles, the Facebooks, and so on, they did that. They looked at the physical world and digitized it. But today what we can do is actually look at this convergence between digital and physical. The internet is not the internet anymore, it's becoming Internet of Things. It's in our cities, it's everywhere. If you look at this room, most of the stuff, the lights and so on is controlled, is addressable, has a number of sensors. There's something, if there's a fire, something will start responding automatically. So we are bringing this kind of digital physical convergence in every part of our lives. And that is changing the way we can think about cities, describe them, and of course, design them. And that's what we try to do. We try to do it with our design office, with, well, first of all, with our lab at MIT, with a small base in Singapore, with our design office in New York, in Turin, actually, and a small base in London, but also with some of the startups that came out of both over the past few years. But so let me share with you a couple of projects where, again, big data and artificial intelligence became part of design and allow us to tackle problems that otherwise would have been intractable in a traditional design sense. Today we can look at a city like this. This is actually a visualization by Pedro Cruz, who was in our lab at MIT. Now he's a professor at Northeastern. This was at MoMA. It's Lisbon mapped using billions of data points collected from the mobility network. And then we can see a city today like this in a way we couldn't a few years ago. A city like a living organism. And if you take the data, you can do interesting things. That's actually similar data in New York. Every dot is a pick-up or a drop-off by a taxi. What you see here is JFK Airport. If you landed there, you might have been one of those dots. If you zoom out, you see JFK was here, and then you see Manhattan and all of the boroughs. A couple of interesting things. The first one is the data was actually made accessible by Mike Bloomberg when he was mayor of New York. Mike Bloomberg is, built a giant company using data. Data today, a lot of artificial intelligence on the data. Again, there is no artificial intelligence unless we have data in order to train it. So the two things are very connected. I remember that Mike Bloomberg in his office in New York had a little sign. He told me recently, he still has it, that went, "In God we trust, everybody else bring data." And so what he did as a mayor was actually open up a lot of data sets, including this one. So we got hold of the data from the Taxi and Limousine Commission, and we asked ourselves a very, very simple question. That question was motivated by what I experienced many times, but I'm sure you experienced many times as well, in New York and other cities. You are at a hotel, whatever, at 7 in the morning, going to the airport, you're there with your luggage, calling a taxi, and then next to you, there's somebody else with a bag. You don't know where they're going. It turns out they're going to the same airport from the same hotel. You could have shared the ride, but you didn't know it. And when we started analyzing this and doing this, Google hadn't launched Uber Pool yet. So we asked a simple question. You got those 2 points in Manhattan. Over the course of the year, you got over 200,000 trips connecting them. How many of those trips could be shared by people by creating a small inconvenience or a small delay? The limiting factor, of course, is the delay in arrival. Say, 1, 2, or 3 minutes, a small delta that you define mathematically. Now, if you want to answer that question, if you use traditional mathematics, it doesn't work. And so what we did here, where sometimes we say big data also needs big math or new math, big data needs artificial intelligence to make sense of it. So we try many techniques, different types of artificial intelligence applied to this. We also developed this system called shareability networks. We worked with Steven Strogas, who's a colleague and friend, professor at Cornell, and as you might know, one of the fathers of modern network science. And so we managed in the end by using this to answer that question. Here you see the shareability networks as they are, and the result was quite interesting, that in New York you could take everybody to destination when they need to be there, give or take 1, 2, or 3 minutes, but with 40% less vehicles than what you have today. Now, two interesting things happened. One is that, well, I remember the first one is more anecdotal. I remember the New York Times reviewed the article when it came out, and they said, well, that's interesting mathematics, but you know what? New Yorkers really don't want to share anything. It turns out that that is not the case, because Uber saw the first results we were getting, and they reached out. We started a collaboration between our lab and Uber, And we did a lot of data analytics and so on. And as you might know today, Uber Pool does exactly that, allows people who go more or less in the same direction to share a ride. And Uber Pool and similar systems now by their competitors, by Lyft, by Ola, by Didi, by 66, you name it, all over the world, by Via in New York. Now they are a significant market globally. I think over 50 billion was estimated recently, the ride-sharing thing. And I think it's good for our cities. It's good for our cities because if you got 2 cars and you share the ride, it's 1 less car on the road. All other things being equal, of course, is 1 less car on the road, which means less congestion, less energy consumption, and less pollution in our cities. So the reason I want to share this with you was really this would not have been possible unless we had a fully digital representation of the city, what we usually call a digital twin, a digital representation of that, and without applying many types of human and artificial intelligence to answer that. I will add something else. I'll show you now a follow-up. But most people see this paper. Again, I show the paper in case you want to look at them. They are on our website. It's a mathematical paper. For me, this piece of work was a design piece of work. Was not looking, if you go back to the definition by Herbert Simon, at how the world is, but was looking at how things could be different in New York, how we could actually change mobility in New York or in other cities and redesign it using data and artificial intelligence. And again, this would not have been possible without using new tools to analyze big data. I'll share with you a few follow-ups. This was a few years ago, as you might guess, because Uber Pool wasn't there yet. A couple of years ago, in the past couple of years, we had a couple of papers that I'll show you now that looked at a similar question, again, big data. We called it the minimum fleet problem. Let's see if the sound also is working. Could you turn on also? Potete il volume? There's no volume. Okay, no problem. I will just present you. But anyway, this is, again, big data, real-time big data in New York. But these are the taxes. And what we did was look at the efficiency problem here. So you see they're vacant most of the time. And how could the number reduce to satisfy the same demand? And what you see here, you see how the algorithm works. We call it the minimum fleet. So what is the minimum fleet to keep Manhattan on the move? And then you see it here, that's a quick visualization of how actually the algorithm and the big data analytics work. Again, it's a design question. How could you redesign the fleets in New York? And what you see to the right is the existing fleets. To the left is what you could do by simply doing optimization. So there's nothing to share, nothing else. You simply optimize the dispatching thing, including looking at tomorrow with self-driving cars, how things could be, which is kind of 50% of the vehicles we have today. So we could run the same system in a different way. Again, this paper was a heavily mathematical paper, the minimum fleet, but again, for me, it's a design paper. Heavily mathematical, a lot of big data, a lot of different type of intelligence in order to analyze it, but again, more like a design paper, looking at how could be a different way to run mobility in a city. The first paper was this one in Nature, and we had another one a couple of weeks ago that builds on that and finds some other big data interesting findings by analyzing all this information. Very briefly, the other thing I wanted to share with you is a totally different project. So the previous projects are from our lab at MIT, where we focus on research. Here's another project. It comes from our design office, so it's more like a more traditional design project, but again, without AI, we would not have been able to propose the system. And that was a collaboration. We led the team together with Ramboll as engineers, Transolar, Ramboll engineers at large, Transolar, German engineers focusing on climate, Danfoss focusing on climate as well. Lean Heat is using artificial intelligence in order to optimize district heating systems. Schneider Electric does a similar thing, again, using a lot of technology in AI applied to networks. OP is a financial institution, SBP, Schleich, Jörg Schleich, one of the greatest civil engineers, structural engineers of the 20th century, doing amazingly lightweight structures in Stuttgart, in Squint Opera for visualizing all of this. I'll share with you a little video about this, but let me see if I can play this sound from here, given that it cannot play from there. So I'll try to do it to run it via the mic. Let's see if this works. we're excited to present to you the Hot Heart, an innovative solution to decarbonize Helsinki. Here is how we do it. And I'll switch to the next slide. But again, in this case, by the way, this was done as part of a competition in Helsinki called the Helsinki Energy Challenge. The mayor decided to do something like a small X Prize. You might be familiar with the X Prize in the US. There's a big challenge, a pot of money, and people from all over the world compete. In this case, it was a similar thing. The problem in Helsinki is that all of the district heating system is actually power, but some industrial plants which are coal-fired. And they want to get rid of coal, and so the question is, how do you heat the whole city? So the mayor did a smaller X Prize, put $1 million as a prize for this. And then there were 250 entries from around the world. We were one of the 10 finalists, and then we were one of the winners announced a few weeks ago. So now we're working to build this. Again, this would not have been possible unless we analyze all of the big data about how the system works. I'll show you a few examples and how we could optimize it again with AI. The key principle is what you saw in the video is very, very simple. So what you see there is the change in wind power prices over time. So the price of generating wind power has gone down a lot. But the problem with all renewables, as you know, is that they're intermittent. So, you know, you get a lot of variation. And that's why sometimes in Finland, as well in Scotland. Scotland is actually the first country last year who was able to produce all of its energy in a renewable way, the large major country, I believe, in the world. That's why Boris Johnson recently mentioned Scotland as the Saudi Arabia of wind. And then, you know, but what you do when that happens and you got negative energy prices, just because there's too much production, where do you put that energy? You could say you take batteries. But the problem with batteries, you see it here, is that 1 megawatt hour of storage is around $200,000. And here you're talking about gigawatt hour. So, you know, it's a huge investment to do it. Some countries are doing a little bit of that, like Australia, but it's super expensive. Now, the other thing you can do is that if you turn that into heat, and here we're talking about district heating in Helsinki, then the storage can be very inexpensive. And what we imagine here with these kind of floating reservoirs, you just heat the water with heat pumps, and then you get to something which is more like $200 per megawatt hour. So the idea is that when you get overproduction on the system, and again, that required a lot of analysis with big data and with different types of AI of the production, then we realize that actually if we're able to get energy when it's low price, or also negative and there's overproduction, then we can turn it into heat. We know that heat is a lower form of energy, but the difference between $200 per megawatt hour to 200,000 is very significant. And anyway, if you want to turn it into heating in the end for district heating, you know, you might well want to do it at the beginning. So this is the system. As you see, you know, AI is actually AI control that was developed by Danfoss and their team is the key thing that can run such a system today. Otherwise, it wouldn't be able to to run it. You see mostly wind, but also other type of energy. It also goes either straight in the district heating system or through the thermal storage. And then, as you saw very briefly, also some additional benefits. As you have these big reservoirs, you can do two interesting things. First is that you can act as an equalizer for the whole Finnish grid. So you can help, load balance the grid. But you can also, as you got these kind of hot reservoirs, why not to create also a great experience? And one important thing in Scandinavia and in Finland is really people during the summer and winter spend a lot of time in the forest, exploring the forest. So why not to create, again, a forest, but another place, an educational place where you can also learn about heating, cooling, about sustainability, just having these 4 tropical forests from the 4 key tropical forests, rainforests on the planet, reproduced there by using some of the extra heat that's generated. So I will stop it here with this, but the point I wanted to make was that, again, I started like Alessandro by looking at AI as something exogenous, and how can we use design to, I would say, almost to domesticate AI. But then I realized that there's the other way to look at it. That actually AI today is the only hope we have in order to tackle some of the very wicked and complex problems. And then perhaps the title becomes something else. It's not using design to humanize AI, to domesticate AI, but it's actually using AI to humanize design. And by humanize design, I mean to make design able to solve some of the wicked, complex problems that we face today, starting from the ones we mentioned, climate change or sustainability in cities, segregation in cities, and many others. So I'll stop here, but thanks a lot.